So, just a little quick introduction to what I'm going to be talking about and about me. I work at Infoblox, and I primarily do IPv6, and I am involved both internally and externally in the company. I go to the IETF. I also work with our engineers on IPv6 issues, and I talk to a lot of our customers. I've been doing internet-related stuff since 1984. Been doing IPv6 for a number of years, and I'm thrilled to finally see some penetration. What I'm going to be talking about today is the fact that as network engineers, we like to think that we keep layers 1 through 3 working, and all that stuff above it is just noise that we don't really have to deal with. And in v4, we've mostly gotten away with that. You know, we sometimes play a little bit with layer 4 stuff and with security stuff, but for the most part, we get to build our networks and let other people throw stuff around on them. v6 is, in so many ways, such a fundamental change that while we can maintain that fiction with ourselves, the reality is that all the people that do play above that, the people that keep servers going, the people that deal with security devices, the people that support desktops, they're going to need our help, or they are going to do things in unfortunate ways that will affect layers 1 through 3 with v6. And so what I'm going through here is sort of a collection of issues and experiences that I have found going around and talking to people who are rolling this stuff out, and the issues that we're already hitting, and the holes that we are already seeing in actually getting through this, so that you can be a resource to all of those other folks. I'm also not going to be filling the full 90 minutes. I've deliberately stuck in some time at the end because I'd actually like to get this interactive, have questions from you or share experiences, because most of what I've got here really is the collected experiences of other folks that I've talked to, customers, folks that I have done talks with, and the rest. And I think that collectively, if we don't share those experiences and then take them back, and I've got some call to actions of what we can do to get everybody, including the vendors and the IETF, helping us. So, as I said, v6 has a huge number of changes from v4. It is not really just a layer 3 change. The IETF, in their infinite wisdom, decided to take the lessons we had learned from v4 and then completely redesign the world. We already know that it's not wire compatible on both sides. The old way of doing things with DHCP has been updated and changed, and there is now stateless auto-configure Slack, which is sort of a fundamental design change with our customers. At my company, we have primarily enterprises who don't like the idea that people magically get addresses that they didn't give them and that aren't in a database already. So the user population was not necessarily well consulted. Most of the world likes the idea that they have some idea of who's using machine based on the IP address. We all know that that's not a really useful security token. Ultimately, it can be counterfeited, it can be misleading, but at least it's a good starting place. One of the other things that happens with v6 and with Slack as well is that there's a lot more magic. You know, in v4, you either statically configured something or you set DHCP and it gave you a certain amount of stuff and that was life. Because of the fact that there are different types of addresses, link local is now on every interface, and it's the same link local address for every interface in a multi-interface box, at least at the address layer. There's a zone or a scope that makes it different, but suddenly you have the same box using the same address on multiple different interfaces. Addresses come and go. There are essentially lease or lifetimes for addresses. There are privacy addresses with even shorter lease times. So all sorts of stuff happens, and you can have multiple addresses on the same interface without doing virtual interfaces. All of these are things that your sysadmins are going to freak at, and your frontline NOC folks are going to take a long time to sort of get comfortable with. One of the other things is that in the same way that Y2K was such a wide-ranging problem that it wasn't just a data center thing. Suddenly you had to get everybody in every department in the company talking in order to do your compliance testing. V6 is going to have that same reach. It touches anything that has a power switch and spits bits on any kind of network. And so security, accounting, sales, IT, all of those people have to sort of buy into all of this and how routing works, and I'll get a little bit more into that with RAs versus DHCP. Suddenly, groups that didn't have to talk before or didn't like or trust each other are going to have to get along, and who does what in provisioning is going to change. For better or for worse, things in V6 have caused applications to actually change how they work. Most people these days think of the internet as web browsing. It's not, but that's certainly what an awful lot of people think of it as, and their window to the internet is the browser. Browsers have always had choices about stub resolvers and various other stuff built into them, but applications are now actually reaching all the way from layer 7 down to layer 3, whether we like it or not. And they are doing things that affect how our network works and the questions we will get from our users. There are policy changes that we may need to deal with. How we use PTR records in particular is something that we're really going to need to seriously rethink. We haven't looked at it in years because we haven't had to. There are any number of things that affect security. The concept of what the broadcast domain is. In some ways it's much cleaner than it used to be, but it's different and we have to understand it. We have to be able to test for it. IPsec has the potential to be different than the current IPsec in v4, and I'll talk a little bit about the perceptions and the reality of IPsec. And in many ways, the biggest problem right now is that this is a continually evolving ecosystem. We are supposedly 10 years into having all of the RFCs done. And the reality is that there are operational holes that are still not covered by RFCs, and there are new drafts and new RFCs being proposed at every IETF every 4 months. And if you think about the fact that if there's an RFC that comes out or a change in an RFC, the amount of time it takes for the RFC to get settled in the IETF, for vendors to implement code changes, for them to test, for them to roll it out to customers to beta test, for customers to acceptance test, and then actually roll out in full production, you're talking a year to a year and a half is a pretty aggressive schedule. Yet every 4 months we're changing everything all the time. So we have to be sort of prepared for the idea that we actually don't get to take a deep breath for several years now. So one of the big changes, MAC addresses. The IETF felt that MAC addresses were fundamentally evil and flawed. And they had some valid objections. Even though they are supposed to be unique, we've all heard the stories of I bought 15 Taiwanese NIC cards and all of them had the same MAC address, and when I put them up on my network, everything just shut down. And even if they didn't start out that way, we all know that most of those cards can have that MAC address altered in software, so you can lie, and bad people can lie, which is why MAC-based security is not exactly a wonderful thing either. And because of the way DHCP works, if I have a multiple interface host and I use a MAC address as my DHCP token, or the key in my database, my lease database, once the first interface DHCPs, I can't DHCP with the others because I'm told I already have an address. And all of those are valid objections. But for all of the fact that obviously MAC addresses are fundamentally evil and fundamentally flawed and can't possibly be trusted, the reality is that everybody on the internet, or the vast majority of them, got on with a DHCP server that identified by their MAC address, and for some reasonable definition of work, the internet mostly works. So obviously, it may be conceptually flawed, but it's certainly functional. what they decided was they wanted to have a DHCP unique identifier, DUID, as the replacement because they felt that they could do a better job. So there are some things they did do right. You only have one DUID for every client or server, each machine. If you are multiple interfaced, you have an identity association or an IA that is unique to each interface. That pairing of the DUID and the IA means that you have a unique key for every network interface, so you can actually now DHCP for every interface on a multiple interface box. That's the cool side. The problem, of course, is, first of all, if you are doing MAC filtering or you are using the MAC address to identify, which certainly every cable provider in the world does, and most IT departments do, you can't correlate V4 and V6 because one of them has a DUID and one of them has a MAC address, and they specifically mandated that you cannot infer the MAC address from the DUID, nor can you count on them having any form of correlation whatsoever. So effectively, you can't go through and keep track. One of the other things is that the way DUIDs work is it's stuck in persistent storage. It's stuck in your leases file, it's stuck in your registry, it's written onto disk the first time that you use DHCP as a client or the first time you fire up as a server, and if you don't have a DUID already. The problem is, I set up an engineering laptop and I do all of my work and I set it up with DHCP and I make sure that everything works. Well, it's going to write DUID into registry or into the leases file on that laptop. If I don't remember to wipe that before I ghost it and then clone it across 15 laptops, so that I have 15 engineering laptops that I know all work, I've recreated the duplicate MAC problem because I've written the same DUID to the disk of 15 machines. So of the objections that we had, it's not guaranteed unique, and it can be altered in software, are still there with DUIDs. And if you do dual stack, which is what we're recommending to most of the folks who can afford it, we do want to be able to have some kind of correlation. And so industry came back and basically said we have to have the MAC address somehow. We don't care if it's the key in the leases database, but we need to be able to get that MAC address. And unfortunately, DHCP v6 relays had that stripped out as part of the protocol redesign. There's a draft for putting that back into the relay, and that helps. And for folks that are doing CMTSs and other things where you're using circuit ID or remote ID as your provisioning identifier, that at least still works. But once again, the IETF didn't really think through what it's going to mean to everybody to fix this problem. Another fun one is happy eyeballs. The original idea was that if you had v6 connectivity, we should encourage you to use that over v4 because we wanted people moving to v6. So if you had a working v6 stack and you wanted to connect to some site or you wanted to make a TCP connection, you did a DNS lookup and you did a quad A first. If you didn't get a quad A, you would go to an A. But if you got a quad A, you would use it. The problem that Yahoo found in 2010 to 2011 when they did World IPv6 Day was they started checking first, and they discovered that there were OSs out there that mistakenly configured IPv6 when they shouldn't, or people built networks where the client might think it had a v6 path to the internet because it had v6 locally, but it didn't. So what would happen was the client would do the quad A, it would try and make a connection, and it would have to wait for that to time out, which could take 2 to 3 minutes to fail. And Yahoo basically said, gee, if 1% of our customer base complain about that, that's hundreds of thousands of users that have this problem. That's unacceptable. So one of the ideas that came out of that was, well, we should try and encourage v6 usage, but the reality is what we want is happy users with happy eyeballs. They want to see content. And if they get it via v4 faster, then that's the right answer. And there is a happy eyeballs draft and now RFC Unfortunately, it's not overly clear exactly what happy truly means. Some people objected of, well, if you're going to do that, that means you're going to do quad A and A record lookups both at the same time, so you've just doubled my user DNS traffic. And if you're running close to the wire, that might be a real problem. The other problem was that all of the OS vendors and all of the browser folks all decided to also be really helpful. And they dived on this before the draft was final, and all of them did their own interpretation of what they should do. Do you sample the network link and see about performance, and if you notice that the v4 link is faster, only do quad A lookups? Do you do quad A and A lookups and see which response gets back to you faster? Some mixture of the two? Do you cache for every IP address you got back, v4 or v6, which were snappier, and then retry them every so often? Well, all of those have been tried. There's a fascinating paper, if you simply Google for hampered eyeballs or hampering eyeballs, and Jeff Houston, who is out of APNIC, he actually did testing of various common browsers and OSs and discovered that all of them did it differently. None of them did it well for all circumstances, and some of them did it worse than the original problem. So this is again into the, we suddenly now need to work with the apps folks and the browser folks and the OS folks to tell them what is a sane implementation. And again, some people fix it at the app layer. Microsoft, for better or for worse, decided, well, amazingly enough, they took the browser isn't the only thing on the network view, which I thought was sort of nice, but they then said, well, obviously that means that we need to fix this at the network layer, and the OS should make all of those decisions, which is okay if you're using Internet Explorer as your browser, because they can coordinate the two. But most users I know on Windows, even though they use Windows, will use Firefox or Chrome, which means that the browser's trying to help you and the OS is trying to help you at the same time, and they don't talk. So, one of the other problems, there's an old joke about two guys talking about the greatest invention in the world, and basically the punchline is one guy says, the thermos is the greatest invention in the world. And the other guy says, what do you mean? He says, well, it keeps hot things hot, and it keeps cold things cold. The only thing I don't understand is, how do it know? And we have a similar problem with v6. We have multiple addresses on an interface that we use to make outgoing connections. And some of those addresses are more appropriate to be used when I'm talking internally within my company. It probably makes sense to use the prefix that's my company's prefix. And it is probably a permanent address. If I have a privacy address because I don't want the rest of the internet tracking me, when I go to the internet, I probably want to use my privacy address. And if I'm staying on link local, I probably want to use link local. And so we get in this, well, how do I know which destination address I should use if I have multiple choices? And how do I know which source address I should use on my packets? And what happens when I have multiple interfaces, all of which have multiple addresses? And I have multiple prefixes, and I'm dual stacked. How do I choose? Well, there is an RFC. It was originally 3484. It was recently redone 6724, which is source and destination address selection algorithms, where there are default rule tables that say things like, if my destination is link local, I should use a source of link local. If I have a prefix that is of length 64, that tells me that it's local to my wire. If it's a 48, that's more specific than a 32. Therefore, if I'm within this space and I have an address that matches where I'm sending it, again, I should probably stay within the address space that I have, because that's probably what you want security-wise. If it's an address that's completely unrelated, and I have a privacy address, I should probably use that. So they came up with all these algorithms. But it's an entire RFC. My guess is that most application developers will never think to ask if there's an RFC to tell them how to do this because they've never had this problem before. OS vendors may have different behaviors of implementing this depending on which C library call you make to open your connection. So you need to think through and work with those folks. Does this work for you? And even if you have all of those, you can choose to override in the kernel the default algorithmic behavior. If you have certain policies that are more specific, which people like governments and the military love to play with knobs like this, they will then change the default behavior. So you can't even count on it being 6724. You have to actually go onto the host and find out if they have changed the default behavior and who implemented it and how. As you can now see, debugging with all of this is going to be exciting because depending on a huge amount of context and when, you don't know for sure until you know exactly what host, what time, what addresses, and hopefully have access to that box, what choice of addresses it had, therefore what it could use. So can you imagine trying to walk an average user or help desk person through figuring out even what source address you used of the myriad you had, and what happens if they don't talk to you till the next day when it's all changed? So there's going to be a huge amount of training that we're going to have in explaining to folks how this works and giving them tools. And unfortunately for right now, the reality is that probably the best tool we have are packet sniffers. And if you've ever dealt with a complex network and security zones, getting the sniffer onto the right wire, being allowed to sniff, and training anybody who's not a networking expert in how to actually interpret what the sniffer tells you is exciting. So hopefully we can express to the world that this is not what we had hoped for. But as I said, when I get to the end, this is the kind of thing that we're going to have to go back to the IETF and go, that was really clever and really elegant, and it makes our life a living hell. Can we lock some of this down and give us less choices? And what haven't we found out yet? I'm already discovering, as I talk to people, one of the requirements of v6 is that if you claim to be a v6 capable stack, you need to be able to accept RA or router advertisement messages from multiple RAs on your wire, and you need to be able to handle all of them handing you a default route. Even if they come with the same priority and the same lifetime and everything else, you need to have some way of coping with that correctly. Now, if you do, the cool thing is that suddenly you don't have to run an active routing protocol on any end host because it handles having multiple default routes to multiple routers with different preferences by requirement as part of v6. So HSRP and VRRP are no longer a necessity. There are places where they may be more appropriate still, but we aren't stuck with them. Note I said in theory, and anybody who's been around the business long enough knows that theory is a lovely thing that we wish for and dream of while we deal with what actually happens in our network. And most of the OSs sort of kind of do this. There's this fascinating problem, and they were mentioning it in the OpenFlow talk before this one as well. You know, vendor says, we support OpenFlow. And you'd like as a customer to go, oh, okay, that solves my technical need. The reality is that you have now essentially started the negotiation process of, okay, what do you mean by support? And do you do this? And do you do that? And how do you do this? And do you have any limitations on this? And Oh, so yes, you filter v6. Oh, ACLs. Oh, but they're done in CPU, not on the line card. Oh, yeah, you support v6 ACLs. Okay. And even something as simple as, can you deal with multiple default routes? You actually have to go to the vendor or test yourself. I have one customer who has discovered that Fedora, at least earlier versions of Fedora, will not fall back to the alternate default routes when the primary default route goes away. They're in the routing table, but it doesn't use them. Discovered that AIX has a fascinating behavior. I was actually brought in because I do v6 for my company, and we had a customer who said, we have a problem with v6, so we'd like to be able to disable it because we are doing DNS through a firewall and it's eating up the CPU. And of course, now the obvious thing is, why did you turn a stateless UDP-based protocol into a stateful firewalled protocol? But that was unfortunately not the discussion I got to have with them. They were not able to change that. They had a security rule that said, thou shalt NAT everything, and therefore you must have a stateful table. But the reality was that they didn't have v6 enabled in their network explicitly, but they had a flood of quad A queries that their DNS resolver was then trying to resolve and going through and overloading this firewall. Turns out that AIX, even when it doesn't have v6 enabled, will still send out a slew of IP6.ARPA resolution requests. And punitively, like hundreds a second kind of query traffic for a box that would never use them. Those are the two most aberrant misbehaviors I've seen lately. That was just in the sort of the month when I was going through this. Part of why I want to have the discussion with you folks at the end of this is to hear more of those. But the reality is that we are learning as we're going what the vendors have done wrong. Because v6 was mostly done in '98, and DHCP v6 was mostly done in 2003 and 2004. And the vendors looked at that, and nobody asked for it. So they either did nothing or they did a half-assed job, and nobody ever complained, so they figured that was fine. The good thing is that we now actually have enough people rolling out v6. The bad thing is we're now discovering what doesn't work that we thought might. Another problem with RAs and the whole idea of how this stuff works. In v4, it's pretty much straightforward. You either set a default route statically when you configure the interface, or your DHCP server gives you a default route. And if the networking folks change everything and they're not the folks that own the DHCP server, one of the problems with that was that they might not change the default route, so clients might actually be getting a broken one. The IETF looked at this and said, this doesn't make sense. People who know what the best default router to use are probably the network architects. They're probably the guys that own the routers, not necessarily the DHCP servers. Therefore, the routers should be the ones themselves telling the client what the upstream choice should be, which makes sense. Well, v6, you also have choices. You can actually statically default route if you really, really want to. But DHCP server can no longer give the default route. So if you're in one of those places where the guys running the DHCP server want to be the ones telling the client what to use, suddenly we've taken that ability away from them because they may not be the router or switch folks. So suddenly there's a coordination point that didn't exist and a lack of functionality. Because the reality was, regardless of what the IETF thought, when we heard we were running out of address space in v4, what most of the world really wanted at the time was v4 with really large addresses that worked just like v4. They weren't looking at auto configuration. They weren't looking at gutting DHCP. They weren't doing, that was the ITF's idea. Unfortunately, reality and politics are that it is different groups for almost everybody. So you have to coordinate things. And unfortunately, the odds are, because of IETF feelings on the subject, default route in DHCP v6 is unlikely to happen anytime in the near future. There are several people very influential in the DHC working group who have basically stated that they will do everything within their power to kill this idea if it ever appears again, and have done so every time it has. So I think architecturally it's a good thing to have the RAs done on routers, but again, it's another provisioning change that if you haven't dealt with this already, you're going to need to start thinking about how to do it, because layer 9 does rule. All right, one of the other things that PTR records. So a short bit of history. Back in the dark ages, when the internet was relatively small and anonymous FTP was how source code was distributed, the founder of UUNet got very tired of people sending emails saying, "I don't understand how anonymous FTP works." So he decided that what we needed was a meritocracy, and decided that if they didn't know enough to be able to correctly put in an inaddr.arpa record for the IP address from which they were FTPing, they obviously were not sufficiently clued to be able to compile code or use FTP, and therefore should just be told to go away. Shortly thereafter, DEC and Washington University, St. Louis, and a couple of the other big FTP archives all said, "Gee, that's kind of a clever idea." And not that long thereafter, people started saying, if I get an inbound SMTP connection and they don't have a PTR record, they are obviously not sufficiently clued to run a well-done system, and their mail stuff is probably screwed up too, so we just won't talk to them. And eventually, it became sort of a security thing, that people would actually do things like do forward and reverse lookups and see if they matched for VPN connections and all sorts of other things that it probably wasn't appropriate to use them for, but we did it anyway. And there are even websites that will do inaddr lookups to decide whether or not to set cookies and allow you to see content, including, last I looked, the New York Times. Didn't help them with China, but okay. So it became this thing that when you got address space in v4, you did inaddrs. And you could do it by hand if you had a lot of Unix literate folks. Most of us did it with scripts. You could do things if you didn't really care what the right-hand side label was, just that it had one. Bind and other things have $generator equivalent to auto-generate all of this. Or you might have some kind of IP address management system, all of which will allow you to pre-populate. In the end, what we did was, because we could do it, we pre-populated everything. So every address we had was pre-done because we didn't know it would break if we didn't do it. Well, that was really cool when you had 256 addresses per subnet, or per /24. Well, let's look at v6. So a single subnet is /64, and you can't go longer than that, which means that you have 4 billion times 4 billion possible addresses for that subnet. The PTR record for that, since it does by nibble boundary, which is so 32 hexadecimal characters plus the IP6 and the ARPA, means there are 34 labels. So if I do the math of 18 quintillion times, let's say, 60 bytes per record, how many people here own enough disk space to hold 164's versus zone file? Ever? Nobody from NASA here? Okay. And so far we have not exceeded the speed of light thing to be able to hold that file in RAM like we do with the v4 zone file. So we have exceeded the bounds of finance and physics for 164. So obviously we can't pre-populate. So what do we do? Well, I have kind of a fondness for the first choice, which is just admit it was a really bad idea in the first place and walk away. Admit that we didn't know everything and just say that was bad. Or get the hardware that could actually do this and pre-populate. It would be kind of cool if we get the hardware. What is likely to be done is, and the place where I feel that it's useful to have those in adders for IP6 ARPAs, large servers and networking infrastructure for traceroute and debugging is a legitimate need. And in most cases, that stuff doesn't change very often, and there aren't that many of them in the grand scheme of all of our address space. We have far more clients than we do servers or networking gear. So we could pre-configure those, and then we get back to scripts, IP address management systems, whatever. That would certainly be the bare minimum that I think that any of us can get away with. I think that beyond that, there is some value to enough people to know who the client is and be able to do those lookups so that websites don't break and we don't get our help desk flooded with why can't I get to the New York Times, that odds are people that care about that stuff will be using some kind of DHCP and let the DHCP server update the zones. The last choice is lying on the fly, which is basically you have a fake zone that any time anybody asks, say, oh yeah, sure, here's the label, never cache anything, never actually have a file. And I know that some of the vendors have been approached to do that for their DNS servers. The issue here, of course, is that if you are doing DNSSEC is specifically designed to not let you lie. So unless you want to do signing on the fly, which means your private key is on your publicly exposed server, and you are hitting the CPU of doing all of the key munging every time somebody does a query, so you've added a really spectacular DDoS vector. So lying is probably not the best route. But it's something that, again, we all probably have policies that say you just pre-populate all of this, we're going to need to rethink it. V6, ICMP v6. In v4, you can literally disable all ICMP, and there are some people that think that they are more secure doing that. It makes debugging a royal pain in the ass. It really isn't that much safer, and there are ways of filtering it so you could actually get aberrant stuff out and still allow things like echo requests through, but okay, fine. You can do this in v4. If you deliberately disable all ICMP v6, which some security folks that I've talked to think they should do, my response is that's really cool, except some of the things you use v6 for, duplicate address detection, to guarantee that there aren't two people using the same IPv6 address on the wire. You can't auto-config yourself, nor can you get RA messages, so you have no default route. You can't find DHCP servers. You can't do PMTU, path MTU discovery, which means that somebody else down the wire who can't handle a packet as big as you send has no way to tell you that's too big, so when they throw it on the ground and then tell you to send it in smaller chunks, you never know, and your stuff just gets bit bucketed. You can't do ping, and you get no network airing messages. So if you don't care about having a bunch of hosts on a single broadcast domain with possibly duplicate addresses, but no external services, no DNS, no DHCP, and you think that's useful, okay, then knock yourself out. Otherwise, you might want to actually think about intelligently filtering. And there is actually a very good RxC that breaks down what you almost certainly should never filter, some things that you might filter depending on whether you need them or not, and some things that almost nobody should allow through other than test labs. And they break them down into sort of those broad categories. I refer to this all the time when I'm talking to security folks, and they're going, what should we do, or why can't we turn it off? I just start with the, have you read this RFC yet? If you haven't, read it and then get back to me with questions. And now, there are two popular myths in V6 that you'll hear all the time. One of them is that there's so much address space we will never run out. To which my response is, 32 bits will be fine because there is no way that there will ever be 4 billion computers on the internet. I quote Vint Cerf, he apologized. And one of the VPs of DEC who said, why would anyone ever need a computer that actually fit on their desk? So as an industry, I think we have a very poor track record of predicting anything. So when somebody tells me we can't ever possibly run out, I just smile and I nod and I go, okay. So that's one of the very popular myths. The second most popular myth is that IPv6 is more secure than IPv4 because it has IPsec built in. Well, there are a lot of things in v6 that are better designed, or that potentially can allow you to have a better, more stable and therefore more secure network than on v4. And it's true that v6 mandated that you must have IPsec, whereas in v4 what happened is it was sort of an add-on, and what we really have is essentially a shared key infrastructure, usually hub and spoke or hub to hub, that is statically configured and scales badly in v4. And the hope was that with v6, much like they had Slack as a way of auto-configuring, that we would have IPsec that would have some better way of doing this. Well, here's the reality. First, the RFC that states that you must support IPsec is likely to be changed to should at the next major BIS revision of the RFC. Not as bad necessarily as you might think, because the US government has what they call the US GV6, the US government v6 profile, which is what all vendors must meet in order to be able to sell to the US government. And one of the things that the US GV6 committee said was, even if the IETF says they will change this to should, the government standard will still say must support IPsec. The more damaging thing was they said must support, but failed to define technically what support means. What that meant was the OS vendors got to decide what does support IPsec mean. And what they decided was support means it ships on the distribution medium for your OS, and if you can install it and configure it and get it up and running, congratulations. So by default, nobody has IPsec enabled. And in many cases, you have to go into interesting places in the kernel, or run special scripts, or run additional daemons, or do all sorts of other things to get IPsec up and running. The other critical failure besides not defining support was, as with so many things, they were unable to agree upon and therefore recommend a public key infrastructure. What that means is that there is no way to have a secret that you can use for your tunnel or your IPsec connection without pre-configuring both ends. Which, if you think, sounds an awful lot like what we have in v4. Yep. So it's one of those good news, bad news. The good news is that if you have IPsec working in v4 and you already have the provisioning process to pre-configure all of the end user devices and all of the termination points of those tunnels, and that works for you and that has scaled for you, then the exact same infrastructure will work for you in the same way for v6, and all of the tunneling architectures you have will be exactly the same. The bad news is that you must provision exactly like v4, and it has the same exact architecture. I have hopes that at some point there will be something like the Dane initiative, for solving certs, or the fact that RPKI for routing is starting to get a little bit of traction, that there will be enough commonalities in a key infrastructure that this will work. Sadly, the sole exception right now to all of this, Microsoft actually did it right. AD authentication is basically Kerberos under the hood. And when you log in with your Windows login credentials, what you're essentially getting is a ticket-granting ticket. What that means is that all you have to configure on the client side is what AD they're in, and then they go to that server, and that server tells them everything else and gives them all of the other secrets they need for all of the other services. So there's a product called Direct Access from Microsoft. If you have a Windows 2008 server configured to do Direct Access and to do AD, every client laptop that you have, when it comes up and you do the Windows login, will be given a credential for doing an IPsec tunnel. And if you don't have working v6, it will fire up Teredo, which works through NAT, works through lousy hotel, conference, airport, all of the other stuff, and you get a working IPsec encrypted v6 tunnel from your laptop all the way through all of the crap, all the way back to your server at corporate, and it looks just like you're plugged into the local LAN, and it's secure as being on the local LAN. And your sales guys won't know the difference because it will just look like another connection on the network, and there's no additional configuration on their laptops. And that's how it should work. You should have one set of credentials that you use that gets you everything, including what you need for IPsec. My pipe dream is that the rest of the industry will be embarrassed enough that only Microsoft has done this correctly and might be in some way encouraged. But if you were talking to vendors for other IPsec products and they want to know what you're really looking for, point them at Direct Access. And now a little bit of IETF bashing, because I love to bash the IETF. Yeah, the more things change, the more they keep changing, seems to be the modus. These are only two of the working groups, DHC and IPv6, and as you will notice, there are a significant fraction of drafts compared to RFCs, and these are the ones that have been approved. Ones that were actually not accepted for work by the working group, there are usually at least a dozen new ones every IETF, which happen 3 times a year. If you actually add up all of the RFCs for everything relating to v6, including Sunset 4, the how do we move from v4 to v6, renumbering, ops, all of the rest of them, there are something like 200 RFCs that you need to read in order to understand how to implement v6, which is insane. Scarily, there are over 200 drafts, which if you cynically then do the math and say that, but that means we're less than halfway done, I'm not sure that's an incorrect categorization of how it's going. And remember way back when I said, well, let's see if the IETF actually did this and made a change, you're probably talking 12 to 18 months before it's in wide deployment in your own network, and that's an aggressive schedule. And they haven't even slowed down what they're writing yet. We're 3 years away from a relatively stable process. We probably should be figuring on at least 2 major rollouts of v6 related stuff a year for the next conceivable future. And for better or for worse, the IETF claims that they want more operational input and that they are writing these standards for the internet and for the people who are making things work. The reality is that if you don't come and burn 5 days every 4 months, sitting through every single working group all the time, you will not be listened to. And so there is a dearth of information. And even if you do go, and even if you step up and you say, no, this is a really bad operational issue,
it's not at all uncommon for them to either say, oh, that's an operational concern, that's not appropriate for the standard, at which point I turn around and go, then who's supposed to be deciding these operational issues that actually make things work? Or they will sit there and they will go, well, that's because your network is broken and you're stupid and you should just redo all your network and all of your gear and then it will work great. Because who here doesn't have the budget to completely redo their network every 6 months? So what can you do? At an absolute bare minimum, you really should be participating. And while it is less effective if you don't go to the meetings, you can be relatively effective by being on the mailing lists. And in some ways, more effective than you think. There are, particularly if you get into the ops area and into things like V6 ops, there they do actually listen to operational concerns. They may not have answers for us yet, but you will not be shouted down as being stupid simply because you have operational issues or concerns that they are not addressing. Certainly, if you can go or someone in your organization can be sent, you should at least go to 1 or 2 IETFs a year, if nothing else, just to see the circus and see how the sausage actually gets made. It does explain an awful lot of things that you sometimes wonder about when you look at the RFCs and then you meet the guys that do them. They are very, very bright individuals, and they have very interesting ideas, but very few of them get calls in the middle of night to fix things that are broken or have to talk to end users who are unhappy. Who in this room does not have some form of pager or user population that they must respond to on a regular basis? Bravo, me either. I got out of support. I'm actually on the product management side now for the first time in my career. Out of pushing on 30 years, I now have a year of non-operational experience. And it is kind of a nice change. But the reality is that we have perspectives on things, and we will look at something and go, that's a really elegant design, but if you poke it there, it's going to go poof, and flames will pour out the sides. And these smart guys will sit there and they'll look at you and they'll go, but why would you poke it there? Because they're users. And that's what users do. Oh. So definitely getting to meet these guys, talking to them, and there are some folks that really do have some incredible operational background. I'm not denigrating the entire IETF. It's just the process is not guaranteed to result in things that will be useful to us if we don't participate in them. One of the other things, there is a talk or BOF or whatever this afternoon, BCOP, Best Current Operational Practices, at I think 4:30. And this is an effort by NANOG to sort of say, these are things that we think everybody should be doing on their network to make the internet a better place, and where we can share our operational experiences and come up with better solutions that we can all use. Jan George, who just came to ISOC recently, is going to be there, and one of the efforts that he and I are trying to start is, I don't know that I would call it an operators union, but it is essentially a way of collecting our common experience and issues so that instead of one company going to the IETF and being told, well, your network's broken, being able to say, well, 70% of the backbone of the internet has this problem, wouldn't you like to address it? I think might have a bit more weight. And on the other side, one of the other things I discovered working for a vendor, I go to the IETF meetings and I see what's coming in the standards and I sit there and I go, oh, our customers are going to want this. This is going to be better for them. And then I go to our PMs and to our engineering staff, and the first question they ask me is, how many dollars do we get? What's the customer that won't buy our box if we don't have this? And if I can't produce a customer and a dollar value, it doesn't get put in the work queue. And most vendors work on the how much have you bought from me lately school of thought. And so again, if we can say 40% of European service providers or 50% of the North American service providers need this in the next 6 months, they can go back to their engineering and to their PMs at the vendor and say, oh, we actually know what the dollar value is now, and it's important. And it would certainly make my life a whole lot more pleasant if I could, whenever I need a new feature, say, you know, here's the user population that cares about this, and here's how I know that. So I would definitely encourage you to show up this afternoon for that. There will be more information this week on the initiative. There's a mailing list that you can join. And the more people we have who have skin in the game, the better it will be. And the last one, which may sound strange, working for a vendor, but beat on your vendors. Getting back to the definitions. Early in my career, I worked for a company that did OSI protocol conformance testing software, back when the government was claiming that OSI was going to be the thing and that TCP IP network was a fad. And it was interesting at the time because I learned that there's a very big difference between protocol conformance, which is what we were testing and what vendors talk about, and interoperability, multiple vendor interoperability, which is what the customers actually thought they were getting and what they wanted. And there's a huge difference between the two of those. We are getting there again with V6 because we don't have an obvious, you must implement this, that, or the other. As I said, if I as a vendor say, okay, I need to implement V6, well, there's a lot of stuff that I don't know if it's mandatory or only needed by a certain portion. Like there's certain things, okay, it's mobile V6, okay, and if I'm not doing mobile, then I don't need to worry about it. Some of them are less obvious. And 200 RFCs with an average length of 20 to 30 pages of very dense verbiage is a painful tome, which most developers will look at and go, yeah, whatever. They'll look at a few of the bit patterns and a few of the data structures, and they'll whip something out, and they'll do the 4 features that were the things that their sales guys actually mentioned, and they'll leave all the rest of it unimplemented, and they'll say, we're done. And so you need to have the detailed discussion. One thing I would recommend, as a matter of fact, is the USGV6 standard. If you Google USGV6 and NIST, it's a document, and in the document, it actually breaks down one of the appendixes. If you are an end user client, here's the parts of V6 that you need. If you are a router or a networking entity, here are the things that you need to implement. And if you are a server, here are the things you need to implement, which is a pretty sane way of breaking it out. And it's actually quite detailed. As a matter of fact, one of the guys that wrote that standard is one of the guys that worked with me at that OSI protocol conformance company a million years back. And he has really good operational background. So USGV6 is a useful standard, and the government said, we don't want you to just read it. We have a test lab. University of New Hampshire's interoperability lab is one of 2 sanctioned labs, and they will run test cases to see if you actually implement what you're supposed to implement according to that standard. So certainly one of the things you can do is you can go to all your vendors and say, are you USGV6 certified? And that's a lot more useful than do you support V6, but it's still, you actually need to look at the V6 standard, USGV6, and see, is that sufficient for you? You may have V6 requirements that are not there, including things like mobile IPv6, that are things that you need. So you need to go. And the other half of this, the chicken and egg thing, I go to our company and I say, we need to implement this new V6 thing, and they go, and who's buying it? And I have to go, well, nobody's buying it right now because they can't roll it out because nobody's implementing it. And so the vendors all say, well, nobody's asked us for it. And then if you go to all the end users and the customers and the rest of them, they say, well, we haven't bothered to plan it or roll it out because nobody has gear ready. Well, if you buy my argument of from the moment you say go to it rolled out in your network, 12 months is an aggressive thing, that means that if you have a V6 feature that you need and your current vendor that you're buying your V4 stuff from doesn't have that feature right now, what you should be saying to them right now is, I'm not buying anything new that isn't V6 capable or that isn't put into your roadmap with a solid date, and here's what I need. Because it's going to be a year before you have something usable. And most of us, if we haven't rolled out V6 completely, are going to need to be rolling it out in the next 1.5 to 2 years, which means we need to be beating on vendors now so that their stuff is actually solid and tested and ready for us in 1.5 to 2 years. So tell everybody you aren't buying anything new that isn't V6 capable, and start asking what they think V6 means and what they have already. Make it detailed, walk through it with them step by step. It makes for some fascinating discussions. I am still astounded at some of the things that I have seen. People say, oh yeah, we're V6 ready. Okay, and like I said, one of my favorites, you can do ACLs? Sure. As long as you don't mind CPU switching them all. So you get 10% performance on V6 versus V4. If that's okay with you, then go for it. I don't consider that V6 capable. I consider that V6 crippleware. So that's sort of some of the broad issues. What I'd like to do now, like I said, is open up the floor or the microphones to either share some V6 brokenness that you have discovered, either with the vendor named or cleansed of the guilty parties, but the basic behavior, or questions about any of the stuff I've covered. No questions at all. You've all rolled out V6 and it works perfectly. Sure.
I don't know much about the RFC, but you were mentioning RFC 6724.
Yes.
I just came from the open flow discussions. It seemed like that's a perfect solution, where maybe instead of a defined set, maybe there's like a best practices, and then you just have open flow. Whoever the entity is, they build their own equivalent rule selections, and if they don't want to follow the best practices, then perhaps they could do whatever rule set they're comfortable, whether it be, let's say, some smaller entity, corporate, or let's say even potentially like a entire cable ISP where they build the rule set to their entire customer base as modems. Again, I don't know enough about open source to see if that would scale to that, but that was my knee-jerk reaction when you were talking about the problems of determining the rule set and then troubleshooting it. And I just came from this lab where they were talking about, well, here's a way where an engineer, the people in charge of the network can actually solve someone's problem by using the server to actually go into their flow and say, okay, instead of you run the sniffer, well, I'll take a look at the sniffer and run it for you. I'll see what your problem is.
Okay, couple things on that. To some degree, OpenFlow and 6724 are different problems. 6724 is for an end host to determine what source and destination addresses it puts into a packet it sends on the wire. OpenFlow rules solve the problem of how routing takes place to get to or between those two addresses. That said, I think that there are several things that are valuable. One of them is, yes, one of the pieces, you can certainly look at the network much more easily in an SDN environment, and I think that there's some value in using a 6724-like rule set as how you do routing as well, because many of the same reasons why you would pick compatible prefixes at both ends are the same reasons why you probably have particular routes that would make more sense than others. It certainly doesn't make sense to have enterprise-specific traffic transiting your external links. but they are different pieces of the problem. And so one of the problems with 6724 and for the help desk is if you can't sniff the wire directly connected to that machine at the time when the user is having the problem, you don't have a way of knowing what the OS picked as the source and the destination pair in the packets it creates before it spits them out the wire. But yes, we are reproducing the same sets of complexities in multiple cases potentially. And OpenFlow is an interesting possibility for a way to homogenize at least the thinking underneath it. And I kind of like the idea of having a 6724-like algorithm as a default setting that you can put into your OpenFlow switches. Does that address? Yeah. Thank you. Yes, and the other for most folks, in places where you can do this, even physically and doing spanning and having a bridge port that gets all of the traffic from all of the ports is handy if your security policy or your physical topology allows you to do that. There are impediments to both, which is why packet sniffing as a troubleshooting method is problematic for a lot of folks. I'm still amazed at the number of places that are utterly paranoid about so many things that they completely break their ability to actually monitor and debug things. Therefore, when they do have a security incident, they've already taken away all their best tools in the name of security. Other questions or comments?
Hello, I'm from Red Hat, and so we're kind of at the end of the internet for you guys. But we have a problem with how we actually will deploy IPv6, right? So we've got provider independent space that's been given to us, and we have 10 internet gateways, right? And they're all over the world. So without doing something like NAT, how do we get that traffic to go out the right firewall and come back in, right? Because since we're doing state, we want to make sure the traffic's not going to be allowed in another firewall, right? So from a design perspective and a rolling out perspective, I mean, how do we do that? We're trying to figure out what to do. So,
I would say for that one, it's essentially the same problem that you would have in v4. v6 actually doesn't improve that problem or improve on that problem much until you do something like have an intermediate layer of routers. If you have routers that are topology aware and understand what gateways you want your users to go in and out of relatively close to the end user population, it's much easier to control. So if you don't have a layer of intermediate routers with an IGP fairly close to all of your end clients already, I would think that you would want to go that direction. You can also, the plus side though, and one place where v6 will help, with v4, you usually don't have enough address space to be able to come up with subnetting schemes that map to policy and routing, saying that this subnet should go out this router because this subnet might have address space from two different chunks of your v4 space, and there might be a third piece over here that doesn't have the same rules but has the same v4 space. It's one of the reasons why ACLs get so messy in v4 is we have sort of patchworks. One thing you can do is think carefully how you want to carve your v6 prefixes so that the address they actually get automatically predetermines to some extent where they're routed, because that makes that intermediate routing layer and the IGP rule sets much shorter.
right, but so then what happens from a redundancy perspective? I mean, I guess your IGP has to know kind of above that where to send it in case this is down, but then you still have the same problem with the firewalls. I'm not going to let that traffic back in. And, well, it's got to go out and come back in. You would lose your connection state, all that stuff.
You'd probably have to have firewalls that allowed one of a pair to get in or out, and you'd have to do pairs of intermediate routers. The plus side, though, is at least with those, you can do RAs. You don't have to do HSRP or VRRP on the end clients. You can simply say, do default route with one of them with a higher preference than the other, and it will use that until that goes away, and then it will fall over to the alternate. And then it gets into you get certain levels of redundancy because if they're in the same data center, you get power supply and actual CPU redundancy with two physically separate boxes. But if they're in the same room, you don't get geographic diversity. You probably don't get ISP or glass diversity. So you sort of have to pick your trade-offs, as with everything else. But yeah, for V6, I think the biggest advantage you'll have is simply that you have enough address space that at least that's one knob that you can give yourself to twirl, and then you're very similar to your V4 problems.
Okay, thank you.
Sure. And the multipath? Multicast. Well, one reaction is that I would love to have the IETF rot in hell forever for reusing a term for something that is different. It is not a flooding tree that we would think of when we think about multicast or MPLS, but we use the same word for it. Multicast in terms of the multicast addresses and multicast ICMPv6, I think it actually is a good thing. When I talked a little bit about the broadcast domain is cleaner, one of the things that, one of my job titles is IPv6 evangelist. And in theory, that means that you're supposed to be enthusiastic about what you're espousing. And I spend much of my time talking about all of the things that are broken or wrong. One of the places where I get to actually tout, this is cool, this is new, this is a win, is in the broadcast domain. Because of the way that multicast works, there are well-known addresses on the local wire for services. So, for instance, DHCP. There is a multicast address that says anybody who is registered to the multicast group that says they are a DHCP server or relay will respond to that address. What that means is when I'm writing my DHCP client for V6, I can hard code the multicast address. I don't have to, go to the broadcast and see who comes back and do this back and forth silliness. I automatically know that whoever answers me is actually the person I'm talking to. And every other server on the wire and every other host on the wire can ignore that. So there are some efficiencies in how much stuff is spit on the local wire and overhead traffic that is actually lower. Now, if we go up from a /24 as an average size subnet with 256 hosts or 254 hosts, if you're ignoring 0 or 1, or all zeros or all ones, and you make the analogous leap to a /64, you obviously are not going to be able to put 18 quintillion machines onto a single broadcast domain. Like everything else, the equivalent of the ARP cache, the neighbor cache tables will overflow, there will be constant churn, there will all sorts of other stuff. We are already seeing people reinventing spanning tree bugs because they didn't learn from history. But because of the fact that there are efficiencies in how multicast works and the fact that you can broadcast things with the first several octets and everybody who doesn't match those can ignore those, you can probably get 15 to 20% more hosts on the same wire before local overhead traffic starts to overwhelm useful data. So, it's not a quantum leap, but it's another safety margin that we all have before we have to repartition, resubnet, and create more VLANs. So I think that part of multicast is good. I think the fact that it does allow coders to hard code certain things in a way that is not short-sighted. I think there are a lot of services that will auto-config much more cleanly. Apple, of course, is trying to move this all over to Bonjour, but because everything should be on Bonjour. But yes, even they are using multicast in V6 in ways that are interesting. So I think it's a step forward. If we could have come up with a better name for it, that's probably my only quibble. And other questions?
Bob Henry, Technical Corporation. You've made some insights into our forecasting capabilities, but thought maybe you would give us your forecast. It seems to me that with this network change, protocol change, I remember living through this hell when we had this protocol called, if I remember correctly, it was IPX SPX. And then we threw IP at it, and we said, oh, it should all work together, except it's Ethernet, and you remember the saga from there. So IPv4, IPv6, so where do you see, really I think the solution is in there. We've already lived this nightmare, and we kind of have to get somewhere else or the other. So I'll just give you the chance to think about that and forecast for us where we're going to go.
Yeah. For better or for worse, I think that the most likely scenarios are going to be people who have a wealth of v4 addresses will dual stack because it is the most robust solution, most being a relative term, as in it is, better to lose your foot than the lower half of your body, but neither is desirable. I think that dual stack is going to have a number of issues that we will discover over time. I think that for people who can't dual stack, for better or for worse, I think that CGN is going to become much more prevalent, carrier grade NAT. It's been working for wireless providers for a while. Most of the things like the 4G and LTE networks are V6 only, and when you get to a V4 site that is not available on V6, they NAT you. The reason that has worked so far for them is because mobile handsets, usage patterns, and applications are not as bandwidth hungry as desktop-based or home cable-based applications. And cynically, there is an expectation that wireless and cellular service sucks. Therefore, when they have poor performance on a V4 site, they are more likely to blame their wireless connection or cell tower than they are to notice that V6 sites work fine and V4 sites suck. So far that has worked well for them because they have smaller populations, smaller bandwidth needs, and a user population that has been led to have low expectations. That is changing in places as providers of actual broadband and WiMAX and other things are starting to use V6 and only able to get V6. But the CGN hardware that's out there is better than it was a year ago. It is punitively expensive, and it is really only for very large providers, and it's going to be like crack. It will be very expensive, very quickly, highly addictive, and very hard to get off of, and will probably be long-term health damaging. Fundamentally, the correct approach, and which interestingly enough has started to happen as of this last summer with the World IPv6 launch, is, and it's sort of like the drug analogy again, trying to bust users isn't useful. Trying to limit supply may be more useful, but giving them something that's a pleasant alternative is usually the most effective. If we get more useful and interesting V6 content and the V4 content that's out there is itself less interesting and less compelling to the majority of our users, CGN performance doesn't have to be as good because it doesn't get used as much. And there were presentations, and these numbers are very old now. I'm hoping to get newer ones now, but as of last summer, 40% of Verizon wireless traffic was going V6 native, and 25% of AT&T WiMAX was going V6 native. And the reason was YouTube, Google, Yahoo, and Netflix were all V6 available. And so as you get more and more content V6 capable, that's going to be the migration path. That sort of answer? And beyond that, in terms of time periods, I love to throw out numbers because I know they're meaningless. If I had to guess, I would guess at the rate things are going, within the next 18 months, the majority of internet traffic will be V6. Majority being simple majority. Why? Because there's enough content and enough other things that are moving that direction, and enough of the bigger folks are moving newer technologies over, and the growth is in mobile devices and handsets and other things. Computer growth is at a much shallower growth curve in use. Things like iPads and tablets and other devices are becoming more usable by more people as a primary device, and more of the home broadband providers are getting tired of having multiple net 10s in their own backbone, which is what drove Comcast to do V6. It wasn't any concern about the greater internet or their customer experience or anything else. Their problem was they had rolled out 3 copies of net 10 and their NOC got confused. So I think that over the next 1.5 to 2 years, we're going to start to see enough usable content that will start to shift. Now, if broadband suddenly makes another leap, because I don't believe that fiber to the home is going to be useful to enough people in the near term other than Kansas City. If that changes, that will change that, because then suddenly the heavy bandwidth use is in a different place. And like I said, I love guessing because I'll be the first to tell you, it's a wild-ass guess. And it's based on several trends right now that I have no way of knowing for sure will continue the way they are. But it does definitely seem that newer technologies and more portable devices are growing at a much faster rate than traditional computing devices, and most of them are using networks where they can't get V4 space. Therefore, they will start with V6, and they will be encouraging their users to use as much V6 as possible. And if, on the other hand, if you want to look at the other end of it, someone actually asked me, when are we going to turn off the last V4 machine? And I said, never. We'll all be dead. We will never know. Yeah. There are still, I go out and I talk to people, and I talk about the issues with V6, and I talk about legacy machines and all the things that you're going to have to cobble together that are never going to get a working V6 stack. And one of the examples I love to throw out is some AS400 in your accounting department, and I have never given a talk for a general business population where there is not at least one person who suddenly has the oh shit expression, confirming my suspicion that someone in the room still has an AS400 running. So, all right, anything else? All right, thank you very much. Have a great lunch.